All right, let's go ahead and get started. I'd like to thank everyone who's joining us today. Welcome to CNCF's webinar, Building a Culture of Observability Within Your Organization. I'm Caitlin Barnard, Marketing Manager at CNCF, and I'll be helping to moderate today's webinar. I'd also like to welcome our presenter today, Grant Schofield from Humio. So just a few housekeeping items I'd like to cover before we get started. During the webinar, you're not able to speak as an attendee, so there's a Q&A box at the bottom of your screen. If you have any questions throughout the webinar, please feel free to drop them in there, and we'll get to as many of those as we can at the end. The session is also being recorded and will be sent out within 24 hours along with the link to the presentation. So with that, I'll hand it over to Grant to kick off today's presentation.
Hi, everyone. It's nice to be here today. Thanks to CNCF for having me to let me talk a little bit about something I'm really passionate about. I've been an operator for a long time. I've been a sysadmin for almost 20 years and been on the internet since I was 13 and using Linux. And during that time, I've seen a really big change in how we build and ship software, but also how we run it and how we manage it, how we monitor it, and make sure it stays up. Previous to Humio, where I work now, where I'm the director of infrastructure, I was the director of infrastructure at Vivo, the music video company. During those years, I spent around 3.5 years there. We were early adopters of many cloud-native technologies. So we were big Kubernetes users. We implemented distributed tracing. We had log aggregation, and we had everything else, metrics and monitoring. So I learned a lot about the changing ways we're shipping software and monitoring it in these very complex distributed systems that we're building today. So today, what I'm going to share with you is what is observability? I think it's a term that a lot of people have different definitions for, with good reason. We'll get into that. We'll discuss a little bit about observability's past, what we did in the past, how the problems that we had, the problems that we're trying to solve, where we're at today, and where observability fits into the landscape today. And then I'm going to look over the next 10 years and pontificate a little bit about where I think observability is going and what's going to change in the way that we make systems observable. So during this whole presentation, I'm going to be talking about how you can make systems observable within your organization. And these systems just aren't your servers and your applications, but there's actually broader applications of observability within your organization and alignment that you can bring from the business side and the engineering side that benefits the users. And that's a key thing that I'm also going to talk about, is the focus on users within observability. So first, what observability isn't. So it's actually not a new concept. It's an older mathematical concept that was used, and we're going to talk about that. Observability isn't monitoring. Monitoring is really just the systems that are alerting me when something goes wrong. And that isn't really observability. It goes much further than that. And it's just not your operations team's concern. Everyone in your organization should care about observability, specifically in engineering, just like DevOps. So culturally, it's really very similar to DevOps. So observability, as it's discussed in the community these days, I took this, synthesized this from a few different places, but it's the intersection of systems, applications, and users. This attribute of systems really is very broad in terms of we're looking at the functionality of our applications, the performance, how testable it is, how maintainable it is, and how monitorable it is. So when things happen in my system, do I learn about them, and can I debug them? So I like to think about it like observability to me is having the right systems and implementations to know how your system is feeling about any request. And what I mean by how your system feels is that we have lots of different requests in many systems coming from across the world. And there are things that can affect certain users in certain countries, be it DNS or be it a CDN. And so having the ability to look at the macro view as well as the very micro view, even an individual user, is really what observability is to me. And how can we tailor our systems to get that result? And the way that I also describe it to others is when I'm looking for that needle in the haystack, observability gives me the context to know why that needle is pointing a certain way. Why is it oriented? Why is it in this layer of the haystack and things like that? And it really allows me to understand all the attributes of that needle. And at the end of the day, this is what I need as an engineer to debug problems effectively with minimal steps. Do I have the information I need about the problem I'm looking at to solve the problem? Most importantly, observability needs to be a cultural facet of your organization, just like DevOps has become today. It's the responsibility of everyone in the organization to care about observability. And this means from the CEO on down, because this data that we're generating with our observability systems can actually benefit the entire organization, be it marketing, finance, et cetera. And observability is going to be different for every organization because what your users are concerned about and what your engineers are concerned about is going to be different than everyone else's. Yes, there are similar attributes in terms of we're all running proxies and load balancers and Docker and things like that. So there are commonalities, but what you actually care about observing in those systems can be completely different. So a little bit about the past. As I said, I've been a sysadmin and a software engineer for over 20 years. So the original idea of control theory came from systems engineering. And so the goal is if we have a complex system, and usually we're talking about mechanical systems or electrical systems, if I put in an input, can I judge what's going to come out of that? So observability came originally from control theory. It's a subdomain of control theory, one aspect of this subfield of mathematics. It was created by Rudolf Kálmán, and in control theory, we're trying to judge the internal state of a system based on external outputs. And the observability is the ability to look at this. So Kálmán's work was really important in the 50s and 60s, in particular with NASA on the Apollo missions and the shuttle programs, in order to develop reliable systems and test those systems before it went up into space. So this field was used not just by NASA, but many other places as well in terms of rockets and complex mechanical systems that have been made for the last 60, 70 years. So it was very formative at the time, and it still is impacting us today. And it's an interesting idea that observability was the word chosen by everyone, but it really makes sense in terms of what the system is and what the theory is in terms of how it is impacting how we talk about it within infrastructure. So observing systems of the past was quite different. Software as a service didn't exist, so we built everything. And when I say we built everything, sometimes we were using something off the shelf, like before Nagios, there was NetSane or Big Brother. There were these systems that we could put together, but we were generally having to assemble them ourselves and provide the data in unique ways, write our own systems to query our databases or look at our processes and our memory usage. All these things were generally done by hand and bespoke for the environment you are working in. There were expensive and ugly tools like HP OpenView and various CA tools to look at SNMP and things like that, but at least being in Linux environments since the late 90s, that was never something we really had access to. Maybe our switches had SNMP, but we weren't really generally spending money on tools like HP OpenView to manage those systems. So we scripted everything, or we died trying. I've done lots of questionable Perl and Bash in my past, and we ran it all with cron. Everything was running via cron, and hopefully, everyone, got bit because, hopefully everyone, learned the lesson that sometimes cron jobs last too long, and then you can build up a ton of cron jobs and take down your system just with cron jobs because it's too busy connecting to different systems and something's happening. So it generally wasn't as reliable as what we have today. And in general, we were rsyncing things around all of the time. So we were rsyncing around configs, we were rsyncing around logs and things like that. So it was very asynchronous at that time. So what are some of the things that we built? This was kind of fun, going back through the past and looking at these systems that we used to run. Now, this isn't mine. I had to go on the internet and find this one, but this is what a basic dashboard would look like. One of the things that I learned when we were running Big Brother is that red and green being good and bad isn't necessarily the best combination, because there are a good amount of people in the world that are colorblind. So it's one of the first lessons I learned about making an observable system is you actually have to care about the UI and how it's going to affect people and how they're going to use it. Now, granted, you could get around this somewhat because you know, the shapes are slightly different, but at the end of the day, expressing the quality of a system in red and green isn't necessarily your best choice. So this is what the architecture of a Big Brother system looked like. So when we talk about distributed systems today and how we monitor, we were doing very basic takes on this 20 years ago with Big Brother. It's a distributed system, and we're using one system to query systems and piping that to other systems. And then one thing that I always remember that's fun to think about is we used to have modems in the data center. The internet, while it's far more reliable today, was pretty questionable back then at times. And when you're running a production system that people are depending on, so at this time I was running a airline reservation system for ITA software in a data center, we needed to know when things went down and couldn't trust the internet. So we actually had modems that were dialing text pagers to actually page us, because that was the only reliable way to do it at the time. So things have come a long way. This is one of the first things that I implemented that I was really excited about, that I thought was going to solve all my problems, were these VRML diagrams of your systems and the health of the systems and how they were connected. But at the end of the day, it was a pretty trick that didn't really solve the problems. It didn't really make the systems more observable, but it gave me a little bit better of a picture of things. Things generally were based on RRD tool. If you're familiar with RRD tool, it's a round robin database. So what would happen is you would have really a lot of data to look at for a day, and then as time went on, you would essentially roll up the data. And so I had a 6-month view, but it didn't have the amount of data. So you definitely could lose outliers and things like that. We were using graphs more for in the immediate problem solving, not necessarily looking back on our past problems. Things got a little bit better with Cacti, things looked better, but it was still fairly asynchronous. We're generating these graphs. It's very static, so I'm generally using a script to generate a list of hosts to make these graphs, or rsync data around and things like that. It really wasn't fluid. And we didn't really have much configuration management at the time. So were these systems observable? Yes, kind of. I don't think they necessarily meet the demands of today or how we look at observability, but what we had in the past, and this is something you'll hear talked a lot about when we discuss observability, is intuition. And I didn't realize it at the time, but I've come to realize over the last several years that intuition is a very powerful tool, and it sets a lot of operators apart from others in terms of they know how the system works in their head, so they're able to picture a database and a load balancer and application servers and know how these systems are connected. And when their graphs get a hump in them, or something happens, they can intuitively surmise where the problem might be in the system and go there and look at it. I think a lot of the work in observability the last several years has been about taking this intuition that a lot of operators have and putting it into software, putting it into code to show us problems. So I think our systems are observable because we understood how our systems were put together, but in general, that's how we operated. There were a lot of limiting factors back then in terms of why we did things the way that we did them. And cost of storage and compute was a lot different. We were graphing a lot of logs. Generally, you would find a problem in a graph and you're logging into a machine and you're tailing a log or grepping a log to count errors or things like that, or to distinguish the errors from not. And there were no time series databases and there was no NoSQL. So we were relying on file systems and databases, and like MySQL at the time. And because the cost of storage and compute was so high, it didn't necessarily always make sense to use those resources for your monitoring. So file systems are generally the lowest common denominator of how we worked with the data and how we moved it around. Because of things like RRD, we didn't really have context of the past. So hopefully when there was a problem and you wanted to record, I have this problem and here's how I fix it, I was generally gzipping up a bunch of logs, maybe some directories of graphs, and saying, here was this problem and here's how I solved it and here's the graphs afterwards. And I was sharing that within my organization, but that takes a lot of people overhead in order to do that, and you have to have a group where everyone's bought into that. If only one person's doing it, it's not nearly as effective as if everyone is doing it. Some of the other limiting factors, I think, of how we think about observability in the past is it was always a sysadmin problem. You know, we don't call them sysadmins anymore, but it was always, you know, the operations group's problem to handle these things. We didn't really have a lot of configuration management. You know, there were a few things out there at the time, but in general, we didn't even have distributed source control. We had CVS and things like that. So the modern takes on configuration management rely on distributed source control, and we have all those things now, so it's much easier today. In general, I think that a lot of the technologies that we're dealing with were, for lack of a better term, enterprisey. And so they were coming out of Cisco and they were coming out of HP, and they were really tailored for those customers. So people working more in the open source world were generally integrating in these proprietary systems, and SNMP was a very, very complex one that, you know, had, you know, all these MIB files and things like that, and it was more for recording your switch and router data and less for other things, unless you're running something like a Solaris or maybe a HPUX. So most of the data that we were generating was statically generated data from logs, and the tools were a very macro view of the world. We didn't have that ability to peer into systems like we do today. And with the way that we run systems today, the approach has to be a lot different due to the complexities. So the sysadmin squad goals back in the past were not letting engineers access production and change things out from under you. I think that since the advent of DevOps and the change in culture and the way that we ship software, this has definitely changed, but that was definitely the norm back then. Having monitoring at all was fairly forward thinking at the time, it seems. There were definitely organizations that didn't have any monitoring, and still today I've talked with organizations who are just now starting to monitor their system, or all their monitoring is very reactive. So getting alerted reliably was a problem, as I mentioned in the past, and so we had to build things in order to do that as well. Uptime was the most important thing, I think. And I'll discuss this a little bit later. Uptime's a little bit easier to come by today than it was in the past, but everyone was obsessed with 5 nines in the late 90s and early 2000s, and that's really what we were working for. I don't think that was necessarily the right focus either, as I'll discuss later. And cross-training and teaching intuition was a very important thing in operations group in the past, because that's how we were able to reason about the complex distributed systems. So fast forward to the present. So we're basically, looking, 10, 15 years out from I think from when Linux really got into the data center or using it heavily. So what's changed in those years? So a lot has changed. Of course, 15 years of Moore's Law, we have all these different technologies that have come along in response to how we're building and shipping software, but all that relies on the newer hardware and things like SSD that make certain things possible that weren't possible in the past. So a lot has changed. And so how do we fit observability in with this picture that we have today, since it's quite different? So the key factors driving observability today, one of the major ones I think that no one talks about a lot is the democratization of technology. So when we talk about containers, arguably it's an outgrowth of VMs. And if you're running in the cloud, you're running on VMs, as it is. So all of us are dependent on VMs. And that technology took a while to trickle down, in particular from VMware in particular. There are other people as well, but in particular VMware. And things like MySQL took a long time. Things like MySQL and Postgres to quote unquote catch up with Oracle, to have things like materialized views and things like that. People used to call MySQL not a database before NoDB came out. So the technology has come along. Some of that is due to that technology trickling down from the more enterprise approaches. So the trade-offs are much different today. The way that I'm looking at my system, building my monitoring system or my observability systems are a lot different because the systems are more complex, and so we need more systems and more complex approaches to manage those. So I would say that observability is becoming more of a first-class citizen in your engineering org in terms of how much money and resources you're willing to devote to it, be that CPUs or people or money. So many organizations are quite comfortable spending a lot of money on a database like an Elasticsearch or Humio in order to store their log data because it's the most effective way to go about debugging the problems today. Whereas before, it was always monitoring, and these metrics were the domain of the sysadmins. They needed to figure out devoting huge resources or whole teams for those things wasn't really practical at the time, but that's changing today. So monitoring is about predicting failure. When I'm deploying my monitoring, I'm doing things like, is this system up or down? Do I have a high number of errors? But all these things are me forward thinking. In setting up setting up monitors to react to specific situations that I'm predicting. Systems fail a lot differently today because they're more complex. It's not just the basic sense of proxy and a bunch of application servers in the era of microservices. These things are more complex. We're using third-party services, be it in an Amazon or a GCP for databases or things like Redis, or I'm using a third-party API to do face detection or things like that. So we have much more complex systems, and it's hard to write your monitoring correctly to take account for all of these complexities. The world that we live in today is far more ephemeral, especially for deploying on the cloud, but I would say that even within the data center, the approach is moving more towards ephemeral systems. The days of configuration management, setting up a server and configuring your server, and that server is going to stay the way it is are fairly long gone, just because of the nature of the systems that are running today and the cost efficiencies we get through having a flexible architecture. Microservices have really influenced, I think, the way that we look at observability, because when you start deconstructing your services into several microservices, you end up getting these dependencies between the two. And in order to debug your system or make your system observable and understand it, you have to understand how those microservices are working together, if there's a problem with one, if there's latency and things like that. So microservices are really driving that as well. More and more companies today are looking to have a multi-region or a multi-cloud setup. And this creates a whole nother level of complexity in terms of, in order to reason about my system, I'm now having to go outside of my data center to understand things. And those things are things like BGP Anycast or DNS or CDNs and all these different technologies that I also have to make observable to understand how my services in the data center are working. The complexity has increased exponentially. I've talked a lot about this in terms of the changes that we've had. Monitoring and metric systems have come a long way in terms of, in the past, generally, the way that we would configure them is we had these static host lists. So I would generate a list of hosts running my web servers, and my check would check those web servers or ping my web servers and tell me if it was timing out or tell me if it couldn't connect and things like that. Well, with the way that we run systems now, especially with Docker, things being ephemeral, our monitoring system has to understand our environment far more than it ever did. So it has to be querying the Kubernetes API and getting the list of pods and things like that, or that has to be built in. We're running far more disparate systems, especially with the use of external APIs these days. And so we also have to understand how our system is interacting with the outside world. And the scale of our applications has increased dramatically. Even if you're running a site that is fairly small, let's say several thousand hits a day, those several thousand hits, if you're using Ajax, which most people are, if they're using React or Angular or things like that, one request can result in tens or hundreds of requests to your server. So the scale of even just a basic application, a basic website, is far greater than it was in the past, where throw a single request to a server, get a 200 back, and get my HTML back. Instead, in order to build that one page, I've seen sites make hundreds of requests to our servers. And so the scale is quite different. So when talking about modern observability, people like to talk about there being 4 pillars of observability. And those are metrics, logging, distributed tracing, and then some people say there's 3. I like to include the 4th. I think it's becoming more common when we talk about the 4th pillar being the user experience. And that usually comes down to your alerting, visualization, or quote unquote monitoring. So how do I make all this data actionable? And how do I have a nice UI that I can go into and debug my systems with? So I'm going to touch on all of these 4 pillars real briefly. So in my opinion, metrics is really a choose your own adventure. More and more people are relying on SaaS, understandably, to solve these problems. And the important thing to remember about metrics is that there's far less overhead than logs, and some people will generally try to get as many metrics as possible. And then one of those things that we do with metrics these days, which is different than the past, is if I have a metric that's, let's say, Nginx 500s or 400s. In order to use that data, on each of my Nginx servers, I'm generally tagging that data. And I'm tagging that data with maybe a host or maybe a process ID or things like that. And so what I'm actually doing, just to store the data in these time series databases, I'm tagging it in order to see that data later. But that can cause problems. There's a propensity to want to add as many tags as you can to get as much context on a single metric as you want, but there's a lot of danger in that. And if you use certain software as a service providers that provide metrics, they will tell you not to tag it with your user UUIDs or any UUIDs, because what that results in is high cardinality. And that high cardinality is a problem when you're dealing with a database. Essentially, I'm having to go through too many tags and process too many tags to actually get at my data. Metrics are valuable because they have far more predictable overhead than logs. It's easier to scale them up and add a lot more than it is to add a lot more logs. Metrics are far easier today because there's lower integration costs, and this is a result somewhat of people getting used to APM and using APM systems and just having a library that instruments my database calls, my cache calls, just instruments these things on my behalf, and so I don't have to worry about it. So it's much easier to get metrics out of the system, but if no one's using those metrics, then it's not valuable to actually save them. And you don't always know which metrics you need, and this goes back to that same concept about monitoring, is that I don't always know which metrics I need in my system. So there is a propensity to just store everything, but maybe I need to build my own metrics based off combinations of things and that. And it's difficult to go back in the past and do that. So the other pillar that we've talked about is logs, and this is the area where Humio operates, and one I'm quite passionate about. And to be fair, I think I didn't realize the value of log aggregation for several years. And I generally would rely on metrics and then go to the logs when I needed more context around those metrics if I wasn't able to reason about them. And that worked really well when we were still deploying systems very asynchronously. But in today's times, it's quite different, and those logs aren't always on the servers. You can't, when your Docker goes away, you need to make sure those logs are somewhere. So I think I've evolved my thinking, especially since coming into the Kubernetes world, and see logs as a very important part of how we make our systems observable. So in general, the challenge with logs is that they are the least standardized in most environments. In general, most engineering orgs, they might use log4j, or they might use insert Winston or what have you in your different environments, but what you're actually logging can be quite different in terms of what one group cares about. They might change the fields. Like, there's generally not the same approach in a lot of organizations. Even if they're doing structured logs like JSON, the fields aren't always the same, for instance. So generating logs is the easy part, storing it is not, and storing it is a hard challenge, and why you see people relying more on NoSQL type databases like an Elasticsearch or Humio in order to store their logs. And you can only really store a finite amount. I can archive them off to S3, but can I actually access them? So it's useful to archive them off to S3 to go look at them, but it's very difficult to imagine even several years from now us storing 10 years of logs in our log management systems and querying it. So, and in general, it's a good idea to sample your logs and generate metrics from them so you can use that later if you do need to reference your logs. So knowing that we had that bump in these services a year ago is an important thing that we can record in metrics and reference the logs so we can go and get the context if we need it. So this is distributed tracing is the newest component of modern infrastructure. And I would say, we're still learning about it, and the way that it's progressed over the last several years is really interesting to me in terms of the open tracing spec and everyone getting on board with that, proprietary software as a service vendors or things like Zipkin and Jaeger. It's really come a long way. However, it's quite difficult in most environments to make it useful unless everyone is using it. So unless you have distributed tracing integrated into your entire environment, all your engineering groups are using it, or you're using something like Istio or Envoy that can give you that. There's a limited amount of utility unless everyone is using it, because then you will have gaps in your distributed tracing. So a good place to start is actually just having correlation IDs. And just a brief talk about how that works. If as requests flow through your system, if you were to add a correlation ID as it came into your system to your first authentication service, you stamp it in the header with an ID. When you request to a downstream microservice, you include that in the header, and then the systems, all through your microservices are also attaching that to the header and recording in their logs. At the very least, I can use that correlation ID to see how a request flowed through my system. And so that's generally a good place to start if you can't really go in on distributed tracing. I'd like to point out that distributed tracing is not quite APM. They're quite different. So I think that there's a lot of synergy between the two, and many vendors are offering distributed tracing along with their APM products now, but they're not quite the same. And so you shouldn't conflate the two. And finally, the fourth pillar, discussing alerting and monitoring. I think that the important thing here for me is that alerting and monitoring are very important, but that's not what makes your system observable. And you need to worry about alert fatigue and making those alerts actionable. Putting developers on call is the right thing to do, but as an operations organization, you need to make sure that those alerts are manageable and include the proper context. And this is the important part about building observable systems. Is it allows you to give people access to debugging this information really fluidly without having to go to 5 different applications and make sense of it and reason about it themselves, because not everyone quite has that intuition about those systems unless they're the ones actively maintaining it. I think that the most important part about bringing a good standard of alerting and monitoring into your environment is really managing it with the way you manage everything else. So making your alerts and your dashboards part of the repositories that you're shipping the code in. And that will give your developers the ability to really easily manage that, as opposed to putting in a pull request to your very big monolithic monitoring system. And that will help people in your organization better interact with these systems, better configure them, and want to use them. And what this really solves is a problem of, in many environments, that everyone has their own Grafana dashboards and they're all pretty much the same, but maybe one tweak later, and we're not really sharing that information with the entire org when we do that. So today, what do we have as our current groundwork? So engineers want APM-ish things. We know that. And so that's really grown out of the DevOps movement. And I think developers taking more of an interest in how their systems are performing. The rise of SaaS infrastructure companies has really changed things, be it a Datadog or a Sumo Logic, SignalFX, et cetera. They've made it far easier to build these systems and not have to run them yourself. So maintaining a 30 or 40 terabyte search system in order to look at your logs isn't an easy thing. And so paying a premium of 30, 40% is worth it for most people, especially when they're smaller. Log aggregation is far easier than it used to be. We have Elasticsearch and Elk and software as a services and Humio, of course. And there's far more options in the past than there were for all of these systems that we're talking about. There's open and closed source options. Open tracing has had a really big impact on making distributed tracing accessible to many people. We're able to run systems of high throughput ourselves. It's not out of question to run a system yourself that can ingest 10, 20, 30 terabytes of logs given proper machines. And it's not that hard to manage. It's far easier than it used to be in the past. So that gives us the ability to store more data, be it more data from today with more detail or data further into the past. And it's far easier to integrate disparate systems today, thanks to JSON. So how can you make your systems observable? So the key for making your systems observable is to really care about the end user. That's why we're, have these businesses, and your end user might be an internal user. Your end user could be a user on the internet. The important part is having empathy for that user. That user doesn't necessarily care about what your CPU load is or your memory usage or how many containers you have and the limits on those containers. Those aren't your user's concerns. What they care about is, did I get an error? Did my login fail? And how slow is this site? So your observability infrastructure should really focus in on these user concerns. And by focusing in on these user concerns, you can tailor your observability goals to those. So how do you go about doing that? You gather as much context as you can from the path of the user. I think that systems are far more observable when they're in our data centers or they're in our Kubernetes clusters or in our cloud, but you really need to expand your observability past that. You need to be taking the logs from your CDNs, your load balancers, et cetera, and bringing those into your logging system and your metrics generating systems. And I think you should even take this further in terms of instrumenting the clients to focus on key experiences. Just briefly, one of the things that we did at Vivo that turned out to be really powerful was we wrote our own, so we did music videos and we had our own video player. And in that video player, we instrumented things like, how long did it take that video to start? How long did the DNS request take in order to look up this round robin DNS? What CDN did I hit? How long did it take for the first frame to start? And all of those things that were useful for us operationally to judge how the systems were working all over the world. In fact, it helped us discover problems with a certain provider in Brazil had lookups of 600-700 milliseconds for our DNS, which is quite slow. So it gave us really interesting data about specific users. And you need to remember that if you have 1 million requests a day and 10% of those fail, that's 10,000 people. That's a lot of requests to fail. So these are things that are worth taking the time to implement all the way out to the client so you really understand how your system is working. So this is why you need to develop a DevOps approach in your organization in terms of observability. So it's a combination of not just your infrastructure team and your application engineers, but even broader than that into your business, your finance, and your marketing. Standardizing your engineering organization's requirements for what people are logging, what they're creating metrics for, if they have tracing or not, will help a lot in terms of driving the usability of these systems. If only one of your engineering organizations is doing this, it's not as valuable to the rest of the engineering org in terms of the observability. I'll have these missing pieces that prevent me from reasoning completely about the system. And these goals are really congruent with the other departments in your business. And it's important not to keep these things a secret. One of the things that was really effective for me in the past is we had engineering town halls, and I was a little mixed on this approach initially, but one of the things we did at the engineering town halls was show what the uptime of everyone in the organization was, how much and how many errors they had. And this was on display. So all of our microservices, hundreds of microservices, here are the top 5 slowest ones, and here are the top, and here was the downtime. And it wasn't about blaming, but it was about, sharing that knowledge across the organization and sharing our triumphs as well. For a long time, we didn't have any downtime for any services for several months, for instance. So new approaches to consider in this modern world. AI machine learning, that's something that I think is just catching on. There's a lot of software as services that are built on this, primarily on this idea, but more and more systems, be it Elk or be it Humio, are starting to integrate things like anomaly detection. And so I think you'll see more machine learning, even at the basic sense, catching on across observability. Adopting a stream processing infrastructure is something I see in larger organizations now, but I think more and more people should look at that instead of using HTTP APIs. Chaos engineering is really powerful. Now that we have these reliable systems and my Kubernetes cluster and all the applications don't go down for 2 months, it's harder for me to predict failure. It's harder for me to write monitors when my system ever fails. So injecting failure into your system with chaos engineering is the new approach you should be looking at, since we have these more reliable systems. Testing in production is an important thing. It's especially when you are at a fairly large scale. It's quite important to look at your production systems and see if certain users in certain geographies have problems. And sampling. Depending on your scale, some things you might want to sample. If you don't have to sample, that's always nice. But sometimes it's inevitable that you do need to sample. So what are the challenges we have today? Briefly talked about this a little bit, but percentiles are misleading at scale. If I'm dealing with tens of millions, billions of requests a day, the 99 and even the 99.9th percentile could be a fairly large number of users, and you don't necessarily know who those users are. You should care about every user, but that one user might be an important business partner that is airing out. So being able to know when they said they had a problem and being able to go find their requests and track them down via IP can be useful, given GDPR concerns and things like that. That may not always be possible, but being able to track down those individual request paths is really important. Log amounts and sizes are just going to increase as people get more comfortable using log aggregation. One of the challenges with building observability systems is scaling and spiky workloads, and sometimes I may need to overbuild my system in order to handle those spikes, but then I'm losing costs. So the observability systems we're building today aren't quite as flexible maybe as they could be. It's hard to run a certain amount of these tools yourself, which makes it easier to go to a SaaS. So maintaining a large Elasticsearch cluster can be complex, for instance. Today, many of the edge integrations we have, if I use Fastly or CloudFront, the way I get that data into my system is still fairly asynchronous. I'm generally reading off of S3, or they're batching up things to send me. So I don't necessarily have that real-time view of what's happening on the edge. A lot of the time we're shoehorning into existing tools, and this leads to a lot of technical debt. So when you're making these choices about your systems or looking to move into another system, don't take those choices lightly. Really consider the trade-offs. I think SaaS can be a challenge because it gets fairly costly at scale. So when you start out and you have 20 microservices and a few million requests a day, it's all fairly reasonable. When you start getting into the thousands of containers and lots of traffic, those SaaS scales can go up too high. And then by the time you're at that point, it's really difficult to build your own. So making those choices or being aware of those choices that you make and those trade-offs up front is very important. And too many engineering orgs I see have different monitoring for different engineering groups in the organization. Some might use New Relic, some might use Datadog, some use Elasticsearch, some use Splunk. Having one approach in your organization is one of the most valuable things you can do. And putting all of the data, at least even if they are in separate clusters due to maybe security reasons, having the same approach and not having two different log aggregation systems is still the right choice in my mind. So intuition is still a very powerful, necessary tool. The software isn't solving that for us today. It's still important to have trained operators who understand distributed systems, who understand software-defined networking, routes, firewalls. All those things are important to have. The observability tools just really infer our intuition. It's never going to replace our intuition. Uptime and mean time to recovery are important still. So the fact that my website is up or down is still important. I don't want to say it's not. But now that we have these fairly reliable systems, even in a multi-region, multi-cloud, that never go down, that's when we really need to, our next focus needs to be the quality user experience and really caring about that, because we already have these reliable systems and 5 nines and things like that. Uptime is far easier to come by. It's far easier to have a load balancer and a cloud organization that can scale to tens of terabytes a day of ingest. So take advantage of that and focus in on the user experience in your system. So some of the best practices you should look at adopting. Remember that not one size fits all or even many. Be mindful of the trade-offs that you're making when you choose to use these systems. Go beyond your engineering organization. Perhaps you should be pulling in data from your CRM about signups or sales or your Zendesk tickets. Lining up the amount of Zendesk tickets you have during a certain time can help you correlate information about users and their geography in your observability system. Being sure to balance the cost and usage trade-offs. One of the things that I found when we implemented distributed tracing at Vivo was that people rarely used it. We were spending a good amount of money to store this data in Elasticsearch cluster, and maybe three users used it a month. And so we were storing 30 days of data, and we made the choice to only store 14 days of data because of that. So you should really be aware of these trade-offs in terms of the cost and usage, and make sure people are actually utilizing the tools. And if they're not utilizing the tools, understand why, and see if there's an alternative approach. And I mentioned this earlier, but have your observability config live with your applications. Deploy it with your CD system, and bonus points if your integration testing is testing your observability systems as well. So when I generate a 500, does it show up in my Grafana? Really basic things like that can be really powerful and help you not miss things that are easy to miss. It's best to start small with one application end to end, even all the way out to the user. By starting small, you get to learn what's important in your organization and what you should be focused in on with regards to the user. As much as you can, maximize the context at every step. So if you are using distributed tracing, consider generating your correlation IDs out on your client from your web application. That's, I think, a really powerful approach that people need to start using. Be wary of edge aggregation because you can lose context, especially in a global environment. So putting together metrics or just depending on your CDN's metrics can give you too much of a macro view at time and not find those needles in the haystack. Canary deployments can be very powerful, especially when combined with chaos engineering and handling that real traffic. And then as an ops person, I always like to say, put your developers on call. I think that is a really good way to improve the understanding of your system. When the application developers are contributing and in the feedback loop to your observability system, you end up building a much better observability system. So going a little bit slower than I had thought, so hopefully we'll still have time for questions. I should be able to wrap this up fairly quick. I'm just gonna briefly talk about the future and what I see coming in observability. We're all gonna have cheaper, better, faster systems and clouds. That's not going to change. I think more and more workloads are going to be moving to the cloud. There's lots of talk these days about hybrid cloud solutions. AWS has one, Google has one. So that's going to continue. The tools we're running are still fairly complex at times and hard to manage. That's going to get easier. And I think that in general, there's going to be less tools in terms of there's a lot of tools that do the exact the same thing, and in general, orgs are using several different tools for APM, for instance. I think you'll see that contract as orgs really realize the benefit of using one tool across your org. Because it's easier to run things like stateful systems in Kubernetes, I think you're going to see less reliance on software as a service because as orgs move to Kubernetes, in order to manage things effectively and keep things simple, running your Elasticsearch or running your Humio in Kubernetes, there is a real advantage to that and having that commonality. So I think as people start storing more data and can more easily run it themselves, they'll have less reliance on SaaS. Things will be more real time. And streaming will be a native part of the infrastructure. It won't be something that big shops only use Kafka and things like that. You'll see more and more people rely on streaming to move data around between their APIs or their logging systems, and doing less HTTP calls and less parsing of files and shipping them places. We're already seeing observability engineers and orgs today. I see job postings for people specifically focused on observability, similar to what SRE was becoming several years ago. So it's really becoming a discipline, which I think is a really interesting thing. Maybe it's similar to SRE, where it only makes sense in engineering orgs with several hundred people. But the fact that it's becoming a discipline in its own, I think is interesting. Users are becoming more first-class concerns for engineers because these KPIs and these things that orgs have are really influencing the application engineers. So not just having downtime, but having a good user experience, and everyone in your org cares about that. I think we'll be sampling on and off dynamically, even maybe by user. So as we get all this data, more and more data, having the ability to look at a subsection of that data. So flipping a bit in my system like a feature flag in order to turn the clients in Brazil on to debug a problem. So telling the clients in Brazil to record their DNS entries or their time to first frame in the case of Vivo is going to be something we're actually going to see, is actually having these dynamic observability systems all the way out to the client. The edge observability will be more synchronous, so companies like Fastly or Akamai are going to be streaming data into us in order to give us observability into what's happening on the edge. And then there should be a general goal to make everything observable in your organization. So maybe your team's GitHub check-ins and how they impact performance. Your repos, I think a lot of these things will be more and more commonplace over the next 10 years. So how do you go about building your observability culture? It's never over. You always need to be asking new questions as you release new products, release new features, be building questions about those systems into your observability system. It always needs to be evolving. Championing the ideas about observability beyond your infrastructure group or your operations group, your SREs, to the rest of engineering is the first step, but getting everyone in the organization, showing them interesting data about how things affect users will really, I think, be of keen interest to other people in your org, be it marketing or CEOs and things like that. Use context from the business to inform you on what your focus should be around users in terms of the amount of trial setups or trial creations you have versus production users, and judging the happiness of the quality of the trial users versus the production users. So understanding what your business is about and what's important to your business will help inform you as to what you should observe. So foster a culture of accountability within your organization. So you own your uptimes and errors. Just because AWS was down, that was a decision your organization made to go in, maybe only one region or not, not take on that complexity. So owning your decisions and owning your observability is really important to building these systems and making them reliable. Empower all of your engineers to make it easy to use these systems. Everyone, instrumenting their code, caring about logging, how they're logging, the number of tags they're using. But it needs to be easier for your engineers to do this rather than a dictate and pull request. And finally, the most important thing is having a culture of empathy for the users and each other. We're all working in businesses towards these common goals. And it's usually about our product or about the people using our service. So having empathy for your users and the quality of their experience, but also that person that got paged because I wrote a bad line of code or I didn't have a proper timeout. It's important to remember that we're all in this together. So I'll close with a quote from Brian Knox from DigitalOcean. The goal of observability team is not to collect logs, metrics, or traces. It is to build a culture of engineering based on facts and feedback and then spread that culture within the organization. So just a few people I'd like to thank at the end. I don't know how much time we'll have for questions. But I'd like to thank my old team at Vivo. I learned a lot. Currently at Humio, amazing group of people. And Cindy and Charity have really had an impact on myself in terms of shaping my ideas about observability. And if you're at KubeCon in the EU, we're at booth 54. You can come by and see me. I'll actually be in Barcelona for that. And if you want to know more about Humio, you can try it for free for 30 days. And we also have a free cloud tier that you can use as well for, I think, less than a gigabyte a day of traffic. So thank you very much. And I will try to bring up questions. Are there any questions? Oh, there it is. What kind of carrots do you give engineers to encourage observability practice? So a lot of these carrots that I give, or the way that I think about it, is to make things easy. So if I make things easy, so if I define that every application in my organization as a CTO or as a VP, every application has to track the number of 500s. So if my SREs create a library to make that happen, it's easy for the engineers to integrate those metrics into their system. So I think it's a combination of making it easy for your engineers, but also if they're getting paged, it'll be easier for them to debug their systems and other people's systems, and it'll make their on-call much, much better. So I think these are the carrots that you bring out. And the last question I'll answer, there were two. Can you explain how chaos engineering relates to observability? I alluded to it a little bit, but more explicitly, when we have these fairly reliable systems with no downtime, I can keep, my Kubernetes cluster didn't go down for, 2 years, and we had uptime for months across all of our applications. It's hard to know how your system is going to react when you don't know how it breaks. So by using a chaos engineering product like Chaos IQ or Chaos Monkey and injecting these failures into your systems, I can see what happens when I take down a microservice or I take down a region in an Amazon availability zone, and I can see how my systems react, and then I can know what monitors I need to set up so I can react to those problems. So I think it's important to start looking at that. In addition, you can make it part of your CI/CD setup. So when you're doing your CI, you can actually inject failures, be it with load balancers or any part of that infrastructure, to actually learn more about that. So if you want to learn more about that, we actually have an ebook that that we released on that. If you can see my screen right now, these notes will be in the slide deck. And so we have an ebook from O'Reilly, from the person at Chaos IQ that wrote specifically about chaos and observability. So I'd encourage you to check that out for more information. Well, thank you all for attending. Caitlin, were you going to hop back on and close it out, or?
Yeah, awesome. Thank you so much, Grant, for the great presentation. And thank you to everybody who joined us today. Just a reminder that the webinar recording and slides will be online within 24 hours. And we look forward to seeing you all at a future CNCF webinar. Thanks again and have a great day.